Embed It Easy is a project based on the development of the tool presented in this video. For the proposed demonstration, the tool has been included in the Gecos source-to-source compiler developed at INRIA, but the tool is not dependent on a particular programming tool and language. The goal of this tool is to automatically optimize the word length of the data in an application that has to be converted into fixed-point coding. The required inputs of the tool are a floating point description of the application as well as a quality constraint. When developing an application for an embedded system, technological specifications are constraining the high-level synthesis of the application before being embedded in the targeted hardware architecture. Commercial tools can be used to generate the RTL description from a fixed-point code of the application. Nevertheless, currently, to transform the floating-point version of the application to fixed-point, it takes 25 to 50% of the application design time. The goal of the tool is to drastically reduce this time. The fixed-point conversion of an application is composed of two parts: the integer part word length determination and the fractional part word length determination. The tool is currently focused on the optimization of the fractional part, which is known as the NP-hard problem. To determine the fractional part word length of the variables of an application, an optimization process is launched. In the implemented optimization algorithm, this process is composed of three steps. First, the minimum word length to meet the quality constraint, while the other variables are set at their maximum word length, is determined for each variable. Then, all the variables are set to their minimum word length, which implies that the application generally does no more meet the quality constraint. Finally, to know which word length to increment, a combination is launched between the different variables to obtain the optimized word length for each variable in the application. The quality at each optimization step is measured through simulations. Currently, the number of simulations for each tested word length ranges between 10 to the 5 to 10 to the 9. The conversion process is long and generally left to a non-optimized stage because of the required optimization time. Contrary to the current methods, our tool is based on statistics, which implies that confidence requirements are fixed by the user. Our tool simulates an adaptive number of points to drastically reduce the optimization time. Here, you can find several tested benchmarks and the obtained gain in terms of number of simulations and time. Now, let's have a look at the tool. Here, you can see all your benchmarks that you want to explore in the different folders. We will be in the demo folder where you have three important files: a compiler script that indicates the C file where the function you want to convert is, a properties file where the user indicates the different information on the exploration to be launched, for instance, the number of points when testing the word length configurations on an inexhaustive input dataset, if you are exploring fixed-point coding or custom floating-point coding, the required confidence on the statistics, the optimization algorithm used, the quality constraint, etc. To indicate that you want to explore the word length between 4 and 32 bits, you indicate it in the field default fix W. Finally, your C function that you have to convert is in the file demo.c, the file that you have specified to your compiler script. The function is written with floating-point data types. You have to indicate the main function to convert in this C file. Here, this is FFT, so I add the pragma main func before the declaration of my function. You also have to indicate how you generate your input data, Here, the input data are XR and XI. These are uniform random numbers between -1 and 1 excluded. And the last information you have to indicate is which data are saved for computing the noise introduced by fixed point conversion. In this case, this is also XR and XI. Then, you launch your compiler script. Gecos will open different windows with the tested configuration of the word length in the +1 part and their associated cost or noise power. The first point is obtained with all the word lengths set to their minimum word length, so we are really far from the noise constraint indicated by the blue line. You get closer from the constraint when you add bits to the word length of your data. In the end, when the solution has been obtained, the point is marked in green. Finally, to check that the statistical estimation of the noise power is correct, the noise power with the obtained optimized configuration is measured on the exhaustive input dataset. The obtained noise power result is indicated here. If you need a quick reminder of the benefits of Embedded Easy, just have a look. Thank you for watching this video.